Hello viewers, welcome to my channel. I'm Hasham. Now I'm going to start the problems on graphical method. Graphical method of solving a linear programming problem. In the previous video, I have explained you about what is the meaning of linear programming problem. It is an optimization technique where we find the solution of a problem where we have limited resources and the resources will have alternative uses. How to utilize the limited resources in order to achieve a given objective. That is linear programming. So how to find out the solution of linear programming problem? Two methods are there, graphical method and simplex method. The easier method is graphical method. In examination very frequently you may get a question on finding out the solution of linear programming problem by graphical method. So before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep ready the problems. Take the screenshot of the points written on the board, then I'll explain every point in detail. Now, see the problem. The ABC company has been a producer of picture tubes for television sets and certain printed circuits for radios. The company has just expanded its full-scale production and marketing of AM and AM/FM radios. The two types of radios the company is manufacturing. First type is AM radios and second type is AM/FM radios. So simply we call it as FM radio. So first category AM radio, second category FM radio. These are the two types of radio the company is manufacturing. It has built a new plant that can operate 48 hours per week. That means maximum time available on the plant is 48 hours per week. We don't have more than 48 hours. So we can utilize either 48 hours or less, but we cannot have more than 48 hours. That is a limitation. Then production of AM radio in the new plant will require 2 hours and production on AM/FM radio will require 3 hours. So per unit time required is 2 hours for AM radio and 3 hours for FM radio. Now each AM radio will contribute 40 rupees to profits while AM/FM radio will contribute 80 rupees to profit. The profit per unit is given. So whenever profit is given, our objective is to maximize the profit. Objective is to maximize the profit. 40 rupees per unit of AM radio and 80 rupees per unit of FM radio. The marketing department, after extensive research, has determined that a maximum of 15 AM radios and 10 FM radios can be sold each week. That means there is a constraint. We don't have infinite demand. We have limited demand. Maximum new units we can sell of AM radios are 15. We cannot sell more than 15 radios. That is a restriction on sales demand. Similarly for FM radio, the maximum radio which we can sell is 10 radios. Maximum. So we can sell either 10 or less than 10, but we can't sell more than 10 for FM radio. Formulate a LP, linear programming model, to determine the optimal production mix of AM/FM radio that will maximize the profit. The first question is, it is asking you to formulate the problem in a mathematical model. After making that, after formulation, then we have to solve the above problem using graphic method. The first question, it is asking you to formulate the problem in a model. Second question is, it is asking you to solve the problem by graphical method. I think all the points I have explained. Now how to proceed? First, we will suppose X1 is the number of AM radios to be produced and sold to get the maximum profit. And X2 is the number of units of FM radio to be produced and sold to get maximum profit. So X1 and X2 are the number of units of AM radio and FM radio to be produced and sold. That is the first assumption we have to make. X1 number of AM radios to be produced and sold to earn maximum profit, and X2 is the number of radios of AM FM radios to be produced and sold to get maximum profit. Now formulation. We have three restrictions. The first restriction is on time available. The time available is 48 hours. So we can make use either 48 hours or less. But we don't have more than 48 hours. Similarly, the sales demand for AM radios, 15 radios only. And FM radios, the maximum demand is 10 radios only. These are the three restrictions. The first formulation of LPP, we have to specify the objective. The objective is to maximize the profit. Each radio, each AM radio gives a profit of 40 rupees. How many radios we are making? X1 radios. X1 AM radio we are making. Each radio gives 40. So total profit will be 40 into X1, 40 X1. Similarly, each FM radio will give a profit of 80 rupees. And how many radios FM radio we are making? X2. So 80 per unit into X2 units. 80 X2 is the profit. So objective function 40 X1 plus 80 X2. This is the maximum profit we can get. Subject to constraints. What are the constraints on the resources? The first resources we have maximum 48 hours. So we can make use 48 hours or less than. That's why the inequality here is less than or equal to. That means we can make use either 48 hours or less than 48 hours. We don't have more than 48 hours. And how many hours are required to make one AM radio? 2 hours. It is given the problem. One AM radio requires 2 hours. So how many AM radio we are making? X1. So 2 X1 plus. How much time is required to make one FM radio? 3 hours. How many FM radio? X2. So 3x2. So 2x1 is the total time for making x1 AM radio. And 3x2 is the total time required for making FM radio. So 2x1 plus 3x2 must be less than or equal to 48. This is the first constant. Second constant, the maximum demand for AM radio is 15 units. We don't have the demand more than 15 units. So our production should also be 15 units or less. We should not make more than 15 because there is no demand. So we can take X1 stands for number of units of AM radio. So AM radio should be less than or equal to 15. Similarly, FM radio, the maximum demand for FM radio is 10 units. So we can make 10 units or less, but we should not make more than 10. So X2 is less than or equal to 10. So these three constraints. This constraint is regarding the plant time available. This is the restriction on demand of AM radio. This is the restriction on demand of FM radio. And non-negativity restriction, X1 and X2 should be greater than or equal to 0. What is X1 and X2? Number of units of AM and number of units of FM. That means the production should be 0 or more than 0. It should not be less than 0. Less than 0 means negative. Can we produce negative units? No. We can produce either 0 or more than 0. But we don't have negative production. So X1 and X2 value should always be greater than or equal to 0. That's it. First question I have to explain how to formulate the problem as a LPP problem. This is the formulation. Right? Half of the question is over. Now we have to solve the above problem by graphical method. Second question. It is asking you to solve it by graphical. Now converting the inequalities into equations and finding out the coordinates at each of the corner point touching the feasible region. The next step, that means the first step in finding out the solution by graphical method is converting the inequality into equation. Here inequalities are there, less than equal to, here less than equal to, here less than equal. Convert it into equation. That means make it equal to. For example, 2x1 plus 3x2 less than or equal to 48. This is the first restriction. And converting this inequality into equation. So 2x1 plus 3x2 is equal to 48. Now, we suppose x1 is equal to 0. Because we think that we are not going to make AM radio. We are going to make only FM radio. So x1 is equal to 0 if we take the 2 into 0 will be 0. 3x2 is equal to 48. So if we take x1 is equal to 0, this thing will become 0. So 3x2 is equal to 48. x2 is equal to 48 by 3, 16. That means the coordinates are, if x1 is equal to 0, x2 is equal to 16. These are the coordinates when we take x1 is equal to 0. Now we take x2 is equal to 0. Suppose, let x2 is equal to 0. So if we take x2 is equal to 0, so 3 into 0 will become 0. So 2x1 is equal to 48. x1 is equal to 48 by 2, 24. The coordinates are x1 is 24 and x2 is 0. The first value is x1, second value is x2. So when x1 is 24, x2 is 0. So these are the two coordinates for the equation 2x1 plus 3x2 is equal to 48. Right? Now second inequality, x1 less than or equal to 15. So less than and equal to we are converting into equation is equal to 15. So when x1 is equal to 15, x2 is equal to 0. Right? Now third restriction, x2 is less than or equal to 10. So we can take x2 is equal to 10. When x2 is 10, x1 is 0. So in this way we have converted the inequalities into equations. Now scale. What is the maximum value of x1? 0, 24, 15, 0. First number is x1. The highest number is 24. 24. So on x-axis we are going to take x1 and y-axis we are going to take x2. So on x-axis we are getting 24 highest value. If we take 1 centimeter is equal to 1 unit, then it will require 24 centimeter. But 24 centimeter is a very long graph. It will not fit on the paper. So what we'll do? We'll take 1 centimeter is equal to 2 units. So on x-axis 1 centimeter 2 units. And for x2 highest value is 16, 0, 0, 10. So what is the highest value here? 16. Highest value is 16. So again, if we take 1 centimeter 1 unit, it requires 16 centimeter. It will be long graph. So we take x2 also. On y-axis also 1 centimeter is equal to 2 units. This scale is required to make the graph legible, clear, understandable. So scale taken. Now you can see the graph carefully. This is the first problem. That's why I suggest you always, while watching the video, keep a notebook, pencil, pen, calculator ready. When I explain, you make a note of it, then only you can be able to remember and easily understand. Otherwise, simply if you watch, if you listen the lecture, you cannot be able to understand properly. So always follow my instructions. So here, this is the x-axis. On x-axis I have taken x1, on y-axis I have taken x2. 1 centimeter is equal to 2 units. Here scale I have taken. So 1 centimeter, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Because highest value is 24 here on x-axis. Similarly, y-axis 1 centimeter is equal to 2 units. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Highest value is 16 only. So we can conveniently draw the graph. Now, we have to plot the coordinates. The coordinates are 0, 16. That means when x1 is 0, x2 is 16. This is x1 0, this is x1 0, x2 16. So at 16 you have to put a mark here. You have to put a mark at 16. So 0, 16. Then next one is 24, 0. x1 is 24, x2 is 0. This is x2 0 and this is x1 24. Now 2 marks we have 16, 24. Now with the help of a scale, draw a straight line joining these 2 points and extending to some extent. Extend the line to some extent beyond the scale, axis. Now, is it less than equal to or greater than equal to? Less than equal to. Less than equal to means towards the origin. So here you have to draw this arrow mark towards the origin. Origin is this one. So here also put an arrow mark towards the origin. This is the first line on the graph. Now second line, second inequality says x1 is equal to 15. So x1 15, x2 0. Only one coordinate we have. Second inequality, only one coordinate. x1 15. So this is x1 and this is 15. 14 and 16. In between 14 and 16 exactly center you will have 15. So at 15 I have put a mark here. Right? Only one coordinate. x1 is 15, x2 is equal to 0. Now draw a straight line, straight perpendicular line. So again, this is also less than equal to. Less than equal to means towards the origin. So draw the arrow mark towards the origin like this. If it is greater than, put the arrow right side. If it is less than, put the arrow left side towards the origin. 2 constraints completed. Now third constraint, x2 is equal to 10. So x1 is equal to 0. x1 is 0, x2 is 10. Here it is 10. Now put a mark here and draw a line, straight line parallel to x-axis from here to straight line with the help of scale. Then draw the arrow mark towards the origin because less than equal to. Less than equal to means towards the origin. So that's why this arrow mark. Here also this arrow mark. So what I have done, I have plotted all the coordinates. I have plotted all the coordinates on the graph. Now, we have to see which is the feasible region. Feasible region means solution space. How to find out? This line says the solution is downward. That means our solution is not above this line because it is showing downward arrow. So our solution is not here. Similarly, this line, this straight line says the solution is towards the left. So we don't have any solution right. Right side we don't have any solution. Similarly, this line, this diagonal line shows that solution space is downward. It is not upward. So this is not the solution. This is not the solution. So finally, this is not our solution. This bounded region is the feasible region. Now shade this feasible region. Now see which are the points intersecting or touching the feasible region. One point is O, 0. 0 is the origin where this feasible region touches. So 0, O, then P. Here, this is the P point where the feasible region touch. And this is Q. This is the area where feasible region touch. And R, this is the feasible region touch. S. So our corner point touching the feasible region are O, P, Q, R, S. You can give any names. So I have given O, P, Q, R, S. These are the points, corner point, which touch the feasible region. Our solution lies at one of the corner point, either O, P, Q, R, S. At one of the corner point is our solution. So the shaded region in the above graph is the feasible region or solution space. This is the solution space. The corner point touching the feasible region are O, P, Q, R, S. O, P, Q, R, S. And the solution lies at one of the corner point. Now we need the coordinates at the corner point. At O, P, Q, R, S, each corner point we need the coordinates. What is x1 value? What is x2 value? Now by observation, we can get easily the corner points of 3 points. Remaining 2 points we have to calculate. Which are the 3 points? O. O means the origin. At origin, x1 is 0, x2 is 0. So at origin, the coordinates at the corner point O is 0, 0. x1 is 0, x2 is 0. We are not producing anything. Then P. At P you can see x1 is 0 and x2 is 10. This is x2. x2 is 10. So at the point P the coordinates are 0 and 10. 0 is x1 and 10 is x2. And S is the corner point. S is the corner point where x1 is equal to 15. x1 is equal to 15 and x2 is equal to 0. So 15, 0. So 3 corner point directly by observation we can get O 0, 0, P 0, 10 and S 15, 0. The other 2 points, that is Q and R. The coordinates of Q and R we have to calculate like this. See here, the coordinates of Q and R can be ascertained as follows. Coordinates of Q. Now check which are the 2 lines intersecting at Q. The 2 lines intersecting at Q are this one. This line is the first line. First equation. Which is the first equation? 2x1 plus 3x2 is equal to 48. This equation represents this line. So I have taken 2x1 plus 3x2 is equal to 48. What is the second line intersecting at Q? The second line intersecting at Q is x2 is equal to 10. Which is this x2 is equal to 10? Third coordinate. This is the third line. So solving the first line and second line, we get the coordinates of Q. So here I have written 2x1 plus 3x2 is equal to 48, x2 is equal to 10. Substituting the value of x2 in place of this first equation, in place of x2 I am writing 10. So 2x1 plus 3 into 10, 30 is equal to 48. Take this 30 to RHS, so plus 30 will become minus 30. 2x1 is equal to 48 minus 30, 2x1 is equal to 18, x1 is equal to 18 by 2, it comes to 9. So x1 is 9, x2 is 10. So coordinates of Q we got 9, 10. Right? Similarly, lastly we need the coordinates of R. The coordinates of R we have to find out. Which are the 2 lines intersecting at R? The first line is this one. First equation, 2x1 plus 3x2, 48. The second inequality is this one. x1 is equal to 15. So x1 is to 15 is the second equation. x1 is equal to 15. These 2 lines are intersecting. So x1 is equal to 15. Now in place of x1 we write 15. So 2 into 15 plus 3x2 is equal to 48. 2 into 15, 30. Plus 3x2 is equal to 48. So 3x2 is equal to 48 minus 30 is 18. 3x2 is 18, x2 is 18 by 3, 6. So x1 is 15 and x2 is equal to 6. So 15, 6 are the coordinates of R. Here we got 15, 6. That's all. 15, 6. Now we have the coordinates of all corner points. O, 0, 0. P, 0, 10. Q, 9, 10. R, 15, 6. And S, 15, 0. We got all the corner points. Now we evaluate the objective function. Objective function is maximize Z is equal to 40x1 plus 80x2. In this equation, we substitute the values of x1 and x2. See the table. Evaluation of objective function, corner point, O, P, Q, R, S. All these points. And the coordinates of O is 0, 0. Coordinates of P, 0, 10. Q, 9, 10. R, 15, 6. S, 15, 0. I have taken all the corner points. Now, objective function, 40x1 plus 80x2. Last column Z value, right? Total. So here 0, 0. That means x1 is 0, x2 is 0. So 40 into 0 is 0. Plus 80 into 0 is 0. So 0 plus 0, you will get 0 as the Z value. First one. Second one, 0, 10. So x1 is 0, x2 is 10. So 40 into 0 is 0. 80 into 10 is 800. So 0 plus 800. 800 is the Z value. Third, x1 is 9 and x2 is 10. So 40 into 9, 360. 360 plus 800. 9 4 is 36. 360 plus 800, you will get 1160. Z value 1160. Next one, 15 6. X1 is 15, X2 is 6. So 15, 40 into 15, 600. 600 plus 80 into 6, 480. 600 plus 480, you will get 1080. Last one, X1 is 15, X2 is 0. So 40 into 15, 600 plus 80 into 0, 0. So 600. Now we got the Z value for all the corner points. Now you locate where the Z value is the highest. The Z value is highest 1160, 1160 at the corner point Q. At the corner point Q. Now we have to write the conclusion. How the conclusion will be written? The maximum value of Z is rupees 1160 at the corner point that is Q, where X1 is equal to 9 and X2 is equal to 10. X2 is equal to 10. Therefore, to maximize the profit, number of AM radios and FM radios to be produced are AM is equal to 9 radios and FM is equal to 10 radios. So if we make 9 AM radios and 10 FM radios, 9 and 10, then our profit will be maximum, that is 1160. If you make any other combination of AM and FM, definitely our profit will not be maximum. The highest profit is 1160 at the corner point Q, where X1 9, X2 10. That's it. This is the first problem on graphical method, how to solve the LPP by graphical method. Each and every point I have explained in detail. So if you want the perfect knowledge, watch this video 2-3 times. Then you can be able to get the complete command on this method of finding out solution of LPP by graphical method. So if you are satisfied, give a like to the video, share my channel among your friends, among your groups, so that more students can watch the video and enhance the knowledge. Give your comments. Subscribe my channel if you have not yet subscribed, and by the super thanks which is given below my video. Inshallah, we'll continue the next problem on graphical method in the next video.